Hey guys, welcome back. In this video, we're going to be learning about the trigonometric functions from Cambridge Additional Mathematics. So first, let's begin with a periodic function. A periodic function is defined as a function that repeats itself over and over in the horizontal direction in intervals of the same length. You can see this everywhere you go. So for instance, if you take a wheel, it always goes in this motion, which is a periodic function. I haven't drawn it properly, but these are supposed to be of same length and they're in the horizontal direction. This portion keeps repeating. So that's why it's a periodic function. And then the period of a periodic function is the length of one repetition or cycle. Okay, let's label this as 2, let this be 0, 4, 6, and so on. The period of this would be 2 units, whatever the units be. It's the length of one repetition or cycle. So that's what this means. And then f of x is a periodic function with period p. If that's the case, then f of p, x plus p is basically f of x. So that's what a periodic function is. Okay, now that you know the definition and we've looked at a few examples, try to solve this. Try to find which of these are periodic functions and which of them are not. I'll give you 2 minutes, pause the video, and then you can come back. I'm assuming that you've answered the question. The first one is a periodic function because this part keeps repeating over and over again. So this is a periodic function. This also is a periodic function because this part keeps repeating and it's of the same length. And then C is also a periodic function because if you look from 0 to 3, the same pattern can be noticed even here. So that's why this is a periodic function. This is not. As you can clearly tell by this, it's not a periodic function. And now what about E? Of course it is. And so is F. And G and H are not. So the answers were A, B, C, E, and F. So these were the periodic functions. And now let's move on to the sine function. We've already learned about the sine ratio, which is basically if there's a triangle and this is theta, sine theta would be opposite by hypotenuse. So that's what sine is, sine theta. So if we graph sine theta, this is what we get. I will tell you the features of a sine function. The maximum displacement from the equilibrium is called as the amplitude. This is the amplitude because from the baseline or the x-axis, this much is the displacement, which is the amplitude, and it's the maximum. And then this would also be considered as the amplitude. A would be equal to 1 because the value of y is 1. So the amplitude is 1. And the period would be 360 degrees. This is the time required to finish one complete cycle. And there are no vertical displacement. If there was a vertical displacement, it would look something like this. This is the graph of sine theta plus 0.5. I will show you some of my notes that I've taken down when I wrote my IGCSE exams. I haven't drawn the graph of sine x, which was my mistake, but you can see this. This is what a sine graph looks like. So let's look at the points. So sin x is a function as it passes the vertical test. In functions, we've learned about the vertical test and what a function is. So I'm not going to go over that again. If you want, you can go to my channel and check out the video. And then sin x is 0 when x is the even multiple of 90. For instance, 0, 90, 360, etc. Sin x, the value of y is 0 when x equals to 0, x equals to 180, and x equals to 360. So you have 3 points where the displacement from the equilibrium or the x-axis is 0. And then you have 2 maximum points. This is the feature of a sine function. And then sin x is either 1 or minus 1 when x is an odd multiple of 90. So an odd multiple of 90 would be 90 and 270. So at 90 degrees, there's a maximum. And at 270 degrees, there's a minimum. And then, as we've already looked at this point before, it's that the sine function is a periodic function because it repeats itself over and over again. So you can keep drawing this sine function from here. It never really stops unless you do. And then the period of a periodic function is defined as the length of one repetition or cycle. And the period of the sine function, sin x, is 360 degrees. Or if you want to write it in terms of radians, it would be 2 pi. And then it repeats every 360 degrees and 2 pi radians. So that's why the period would be the following. And then we have this small note that sine 2x has a period of 180 degrees. Let me show you the graph of sine 2x. Let me clear this. If this is sine x, then it will look something similar, except it will be scrunched. So it may not make sense right now, but I'll just draw it for you, and then you'll understand. This is honestly a really bad graph, but please just try to understand instead of looking at the thing. Okay, so this is what sine 2x would look like. The period has reduced by a factor of 2. So it would be 360 divided by 2. So that would be the period. The amplitude remains the same at 1 and minus 1. If you multiply the value of x by a constant, the period would decrease by 1 by that value, which is a. So that's how you draw it. It would be 180 degrees. So that's how you change the period of a function, or like the sine function. Then the amplitude of a periodic function is defined as the distance between a maximum or a minimum point and the principal axis. So the maximum distance, the distance between the principal axis and the highest point. So it would remain 1. And now the basic sine function sin x has an amplitude of 1. Because sine 2x is multiplied by a constant, which is 1, the amplitude would be 1. If it were 2 sine 2x, then the graph would look something like this. Just imagine this is point, here's 2. It would look, and let me draw this in this color. It would look something like this. The period would remain the same. Now let's just say this is 2 sine x. This is the graph of 2 sine x. The amplitude is increased by a factor of 2, so it's doubled. The period remains the same. So yeah. And then here's the graph of a into sine x. This is what the graph of sine x looks like, and this is 2 sine x. So the graph of y equals to 2 sine x is a stretch of the graph of y equals to sine x. It has been stretched from the x-axis with a stretch factor of 2. And the amplitude of y equals to sine x is 2, and the period remains the same, which is 360 degrees. If you multiply sine x by a constant, it will be stretched by the same factor from the x-axis. So that's what a sine theta or sine x means. And then similarly, the graph of y equals to 4 sine x is a stretch of y equals to sine x from the x-axis with a stretch factor of 4. The amplitude will be 4 and the period will remain the same. Let's look at the next factor. If we have y equals to sine bx, we've already discussed this, that if you have bx, the period would be reduced by the same factor as 1 by that. This is the graph of y equals to sine x, and this is sine 2x. There are two more cycles that can be drawn in the same space as y equals to sine x. So the graph of y equals to sine 2x has been stretched from the x-axis with a factor of 1 by 2. The amplitude remains the same and the period would decrease by a factor of 2, which is 180. And then the graph of sine x, it would be stretched by a factor of 1 by 4 from the y-axis. And the amplitude would remain the same, but the period would decrease by a factor of 4. So 360 by 4 is 90 degrees, or it can also be written as pi by 2. So this would be the graph of y equals to sine 4x. Now let's look at the final factor that could affect the graph of sine x. So y equals to sine x plus c. It is a translation which is vertical. So if we have y equals to sine x and we have y equals to sine x plus 1, it would move vertically up by 1 unit. So the graph of y equals to sine x plus 1 is a translation of the graph of y equals to sine x, and it has been translated by the vector 0, 1. So this has been moved up by 1. And then the amplitude would remain the same and the period would also remain the same. And similarly, the graph of y equals to sine x minus 1 would be a translation downwards by 1 unit. So the vector would be 0, minus 1, and the period and the amplitude would remain the same. But the maximum and minimum points would change, but the amplitude remains the same. So this is the conclusion. If we have a sine bx plus c, then the amplitude would be a, the period would be 360 by b, and then it will have a vertical translation of 0, c. So that's what we have learned so far. This is the conclusion. It's really important. This is really important to know because sometimes you'll have to plot the graph in your exam. And now try to fill the table. If you've understood the concept, then this should be easy. Okay, if you're done, just unpause the video and I will work the answer with you. So the maximum, okay. So the first question is y equals to sine x. The maximum would be 1, the minimum would be minus 1. The period is 2 pi and amplitude is 1. And now let's look at the second one, which is y equals to sine x plus 3. So we know that the max of this would be 1. So 1 plus 3 is 4 and minus 1 plus 3 because the minimum value of sine x is minus 1. So minus 1 plus 3 would be 2. And the period would remain the same and amplitude would also remain the same. And now let's look at the next one. We have y equals to sine x minus 2. The maximum value of sine x is 1. So 1 minus 2 would be minus 1. And the minimum of this would be minus 1, which is minus 1 minus 2, so minus 3. Period would remain the same, amplitude same. Now we have this. This would be 1 plus c and minus 1 plus c. The period would remain the same and amplitude would also remain the same. Now let's look at the second question. They've written down the answer. The maximum and minimum would remain the same. The period would reduce by a factor of 2. Amplitude same. Same. 2 pi by 3. 1. This would be 1, 1, 4 pi because 2 pi by 1 by 2, which is 4 pi. And amplitude same. This would be 1, 1. This would be 2 pi by b. Amplitude 1. So that's our answer. Now let's look at the last question. This one. This deals with amplitude. So maximum is 2, minimum is minus 2. Period remains the same. Amplitude would be 2. Similarly, this would be 3 minus 3, 2 pi, 3. And then maximum would be 0.5 minus 0.5. And 0.5. This would be a minus a 2 pi and amplitude is a. So now we've filled the table. Now let's solve a few questions. The first one states the following. Without using technology, sketch the following graphs for 4 pi, between 4 pi and 0. Okay. We know that this is how the graph of sine x looks like. Let this be pi, 2 pi, 1, minus 1. This is how it looks like. My bad, 1 second. Doesn't look like that. It looks something like this. It's not perfect, but it's fine. This is how the graph of sine x looks like. And now we have 2 sine x. So we know that this is the amplitude. Hence, this would be 2 minus 2. And now they want between 0 and 4 pi. So therefore, we have to extend this. This would be 3 pi, 4 pi. And the cycle would repeat. This is how it looks like. This is y equals to 2 sine x. Now let's solve the second one on the same axis. This would be 1 minus 1. Okay, the amplitude for the second question would remain the same, which is what, like the usual of sine x, would be 1 sine 2x. But the period would be 180 degrees or pi degrees. That's because x is multiplied by a factor of 2. Okay, so this is how it would look like. Is y equals to sine 2x. Now we'll do sine x minus 1. So first let's draw sine x. Sine x will look, not this color, let's draw in green. So let's draw sine x. This is the graph of sine x. And sine x minus 1 would, it would translate downwards. So this is how it would look like. So this is the graph of y equals to sine x minus 1. So we're done with this question. Let's move on to the next one. So we have to find the values of a, b, and c. Given that the function y equals to ax plus b plus c, it's given that, and then a is greater than 0, b is greater than 0, and it has an amplitude of 3. We know that a is dependent on the amplitude. So a would be 3 because it's stated here. B would be 1 because 2 pi by 1 is 2 pi. And principal axis of y equals to 0, so c is 0. That's for part A. Let's look at part B. Amplitude 2, so a equals to 2. B would be 2 pi. So we know that 2 pi by b is the period. So therefore b would be 5. And c would be 6. Now let's look at the last one. A is 5, b is 3, and c is minus 2. Let's look at the answer. 2, 5, 6, 5, 3, minus 2. So we got the answer. Moving on, let's solve the last question. We have to draw the graph of the following. Let's start with y equals to 3 sine 2x minus 1. Okay, first let's draw the graph of y equals to sine x. This is the graph. Wait. This is y equals to sine x. Now the amplitude is 3, the period is pi, and it's translated by minus 1. So first let's draw this part. So it will go something like this. This is because this is 3, this would be minus 3, and the period is pi. So this would be 2 pi, this would be pi, and this would be 0. Now we just have to translate this 1 unit down. It looks something like this. It's not perfect, but I hope you get the idea. So this is the final answer. Let me use a different color for that. Sorry. This is not how it's supposed to look like, but I hope you get the idea. This graph is terrible, so I will show you what it's supposed to look like. Okay. So this is how it's supposed to look like. This. As you can see, the amplitude is 3 because this is -4, 2, and half of that would be 3. And it's translated 1 unit down, and you can see that it finishes 2 complete cycles in 2 pi radians. So this is how it's supposed to look like, not this. This is a really bad drawing. So I'm not going to draw them now, I'm just going to explain, and then I'm going to graph it using Desmos because as you can see, it's not a really good graph. You can't really understand this. So I'll just explain it. The amplitude would be 3, no 5. And then there'll be 4 cycles and it will be moved 3 units up. So let's graph this. 5 sine 2x plus 3. This is how it's supposed to look like. The principal axis is over here at y equals to 3. The amplitude would be 8 minus 3, which is 5, and completes 4 cycles. Not 4, sorry, 2. So 1 cycle, 2 cycle. So I hope you understand. Now let's graph this one. The period would be 2 pi by 3. This is how it's supposed to look like. The principal axis would be y equals to -2, and it would finish 3 complete cycles. Now that we've finished the questions, let's move on to the next topic, which is the cosine function. This is very similar to the sine function, except it is translated through the horizontal axis. Yeah, so it starts with 1 at like cos 0 would be 1, and then you see the same pattern as you saw with the sine function. And then it's gonna have zeros at 90 degrees and 270 degrees, and we have 2 maximums and 1 minimum, and the minimum occurs at 180 degrees. So as you saw, the sine function looks somewhat like this, the thing that I'm tracing right now. This is how the sine function looks. So if we move it this side, this is what we get. So it's essentially a translation of, by the vector -90, 0. Okay, now I'm going to show you some of my own notes. I was supposed to draw the function, but like I was too lazy, so we'll just ignore that. The cos x is a function as it passes the vertical test. A vertical, yeah, also ignore the spelling. So a vertical test is a test for a relation. So if it passes the vertical test, it means it's a function. Cos x is 0 when x is an odd multiple of 90. For example, 90 and 270, as we can see here. And then cos x is either 1 or -1 when x is an even multiple of 90. At 0, we have a maximum. At 360, we have a maximum, and at 180, we have a minimum. And then cos 0 and cos 60, yeah, that's function. Then cos x is a function. The cos function is a periodic function because it repeats itself over and over again. So if you continue to draw this, you're going to have the same exact graph over here too, starting with 360 and ending at 720. Okay, the period of a periodic function is defined as the length of one repetition or cycle. We've already gone over it, so I'm just gonna skip this part. And then it's very similar to the sine x graph. So even here, cos 2x has a period of 360 by 2, which is 180 degrees. So to find the period, we have to divide 360 by b, which is basically cos bx. And then the amplitude is defined as the distance between a maximum point and the principal axis. So the amplitude for this would be 1 because this is the principal axis and the maximum occurs at 1. So the amplitude here also is 1 because negative 1, 0. Anyways, let's move on. Then the basic cosine function has an amplitude of 1. As you can see in the graph, it has an amplitude of 1. I'm just gonna brush past this really quickly because we've already done something very similar with sin x. So this is the graph of cos x, and this would be 2 cos x because the amplitude will double because we have the value of a as 2, and then it's a stretch of the graph of y equals to cos x, and it is stretched from the x-axis with a stretch factor of 2. And the amplitude of y equals to 2 cos x is 2, and the period remains the same, which is 360 degrees. Similarly, the graph of y equals to 3 cos x is a stretch of the graph y equals to cos x from the x-axis with a stretch factor of 3. Amplitude is 3, and then the period remains the same. Okay, now that we've covered what y equals to cos x does, let's look at cos bx. So as we discussed previously, the period is gonna be 360 by b. So if we have cos 2x, then the period would be 180 degrees. So it keeps repeating. For every 180 degrees, you're gonna have one cycle. The graph of y equals to 2 cos x has been stretched from the y-axis with a stretch factor of 1 by 2. So this is the y-axis, and it has been stretched by a factor of 1 by 2. And the amplitude of this remains the same, but the period would become 180 degrees. And similarly, the graph of y equals to cos x by 2 has a stretch factor of 2 from the x-axis. And the amplitude is 1 and the period is 360 by 1 by 2. So it's 4 pi or 720 degrees. So as you can see, we complete a full cycle between 0 and 720 degrees because the period is 720 degrees. And finally, we're going to look at translation. We have cos x plus c, then it's going to translate by the vector 0, c. So this is y equals to cos x, and then we shift that 1 unit up. So this is what we get. So this is the explanation. It's very similar to the sin x one. So the graph of y equals to cos x plus 1 is a translation of the graph y equals to cos x. It has been translated by the vector 0, 1, and the amplitude of y equals to cos x is plus 1 is 1, and the period is 360 degrees. The graph of y equals to cos x minus 1 is the translation of the graph y equals to cos x by the vector 0, minus 1. The amplitude of the graph of y equals to cos x minus 1 is 1, and the period is 360 degrees. So when you translate something, the amplitude and the period does not change. So this is the conclusion. Very similar to the sin x one. So we have y equals to cos a cos bx plus c. The a factor would affect the amplitude, and a would be the amplitude of the graph. B affects the period, and the period would become 360 divided by b, which is in degrees, or 2 pi by b in radians. And then c affects the translation, a vertical translation that too, and the translation would be 0, c. So that's all you need to know about the cosine function. So now let's solve a few questions. Let's look at the first question. Without using technology, sketch the graph of y equals to 3 cos 2x for the domain between 2 pi and 0. Okay, I will try my best, but as we have clearly established, I'm not a good drawer, so I will just try my best. Okay, so the amplitude would be 3. So let's say this is 3, this is minus 3, and the period would be 180 degrees. So this would be 360 and this would be 180. Okay, so we start with 3 and we go down and then go up. That's terrible. Okay, we got to do that again. Okay. So they told us to do this without technology, but we definitely need to. So I'll just type in the thing here. So this is what it's supposed to look like. It looks somewhat similar, but this is how you're supposed to draw it. So when you're drawing it on paper, it's easier because you can plot the points, but then on the screen you can't really do that properly. So yeah. Now let's look at the next question. We have to find the cosine function for the following graph. Let's use the concepts we have learned to solve this question. Alright, so we'll start with the first one. Over here, wait, let me use a different color. Okay. We can see that the principal axis is clearly y equals to 0, my bad. It's y equals to 0 because above this line and below this line, we have the same amplitude. So the value of A would be 2. Alright, so now that we've established that, we can clearly see that there is no translation, there's no vertical translation or horizontal translations. Although you don't need to know the horizontal translation, it's fine, you don't have to know that. Anyways, we can see that it completes 1, 2. It completes 2 cycles from 0 to 2 pi. So the period is 180 degrees, and we know that the period is 2 pi by b. Let's just write pi instead of 180 degrees. So this would be pi. This would mean that b is 2. Therefore, of y equals to the amplitude into cos 2x. This is our answer. Let's move to the next question. Okay. This has vertical translation. If we want to find the amplitude, what we can do is subtract the maximum minus minimum divided by 2. So that will be 3 minus 1 divided by 2. No, we're not finding, yeah, okay, never mind. This will be 2 by 2, which is 1. So the amplitude would be 1. And the translation C would be 2, because this is the principal axis, right? And then we are moving up by 2 units. So therefore C would be 2. And now we have to, wait, let me clear this. Now we have to find the period. We can see that it completes the cycle between 0 and 4 pi. So it takes 4 pi units to finish one full cycle. So therefore, 4 pi equals to 2 pi by b. b is therefore 1 by 2. So our final answer would be y equals to a cos bx plus c. Now let's substitute the values in. This would be 1 cos 1 divided by 2x plus 2. This is our final answer. Let's verify the answer. This is exactly what we got. So I hope this concept is clear. Try to solve as many questions as you can to familiarize yourself with the type of questions that might come. Okay, so now we're going to move to the tangent function. This is kind of different from what we've seen before. Over here, the period would be pi. Over here, before in cos and sine, the period was 2 pi. But in the tangent function, it's pi. And there's always a vertical asymptote. So I hope you know what an asymptote is, but if not, don't worry. So an asymptote is like a value that the graph approaches but never reaches that point. Over here you can see that it will get like infinitely close to this line, but it never crosses that line. So it's never equal to that point. So I hope it's clear now. Okay, moving on. So the vertical asymptotes are always at x equals to pi by 2 plus k pi. Yeah, that's all you need to know. And this is the shape of the graph. It looks somewhat like this. It just goes like this. I don't know how to describe it, but I hope it's understandable. And now let's look at some additional notes plus questions. So the general tangent function is y equals to a bx plus c. And a must be greater than 0 and b also should be greater than 0. And the principal axis is y equals to c. And then the period of this function is pi by b. Before it used to be 2 pi by b for sine and cosine, but for tangent, it's going to be pi by b. And the amplitude of this function is undefined. The reason for this is because it always increases. This function is never ending. This will keep increasing. So the value of y will keep increasing in this direction, and it will move towards the negative infinity in this direction. So therefore it's undefined. If this is clear, let's move on to a few questions. First, try to solve these questions and then we'll work through it together. Okay, now let me read the question. Find b and c given that the function y equals to tan bx plus c has a period of 2 pi by 3 and a principal axis of 2. Okay. We know that the value of c is essentially the principal axis, which is y equals to 2. So therefore, c is 2. Pretty simple. And now we know that the period is pi by b. And they've given us the period, which is 2 pi by 3. Therefore, it's going to be pi by b. And b would be 2 by 3. So we got our values of b and c. B is 2 by 3 and c is 2. Let's do the same thing for this. C would be minus 3 and the period is pi by b and the period is pi by 2 in this case. So therefore b is 2. B is 2, c is minus 3. That's what we also got. This is all for the cos, sine, and tan functions. Now we're gonna go about trying to solve equations and we're gonna learn a bit more. Okay, so let's look at this question. We have to solve x on the domain 0 to 4 pi. And And our first question is 2 cos x minus 1 equals to 0. 2 cos x minus 1 is 0. Therefore, cos x is 1 by 2. Now to find the value of x, we have to do cos inverse of 1 divided by 2. If you plug this into your calculator, you get pi by 3 radians. And now the second value would be 2 pi minus pi by 3, which is 5 pi by 3. So this is in the domain 0 to 2 pi, and but the question states 4 pi. So therefore, our third value would be 3 pi plus 2 pi, pi by 3 plus 2 pi, which is, let me see, 7 pi by 3. And our fourth value would be this, which is 11 pi by 3. This is our answer. Let's solve the next two questions. We have sin x is 1 by root 2. So sine inverse of 1 divided by root 2, it's 45 degrees, which is pi by 4. And now the second value would be pi minus pi by 4, which is 3 pi by 4. Our third value is pi by 4 plus 2 pi, which is going to be 9 pi by 4. And fifth answer would be 3 pi by 4 plus 2 pi, which is going to be 11 pi by 4. Yeah. Okay, this is the first, second, third, fourth. Let's do tan x equals to 1. So x will be tan inverse of 1, which is also 1 by 4 pi. And x would be pi plus 1 by 4, which is 5 pi by 4. Third and fourth value would be plus 2 pi, which is 11 pi by 4. And then 5 pi by 4 plus 2 pi, which is 13 pi by 4. These are our 4 answers. If you're getting confused with this, look at my previous playlist and then it'll be clear. Okay, now let's solve this. I'll just solve it here only. We have to solve this for the domain 0 to 5 pi. So cos inverse of minus 1 by 2 is 2 by 3 pi, and then it will be pi minus that, not pi, sorry, 2 pi minus that, which is 4 by 3 pi, and then we just got to add 2 pi to this, plus 2, it's going to be 8 by 3 pi, and 10 by 3 pi. And now let's try to add 2 pi to this. It's still in the range, so the final answer would be 14 pi by 3. This is the answer. And let's solve this question. We have sine x equals to 1 divided by 2. Now if we take the inverse of sine, we get x equals to 1 by 6 pi. And the second value would be pi minus that, which is 5 by 6 pi. And now we got to subtract 2 pi from it. We get minus 7 by 6 pi. And then when we do 1 by 6 minus 2 pi, we get minus 11 by 6 pi. Just like, I think this is 2 pi and 2 pi. Minus 2 pi and 2 pi. Yeah. Okay. Now we're done with this question. Now let's look at the answer. Let me just move it here. Okay, we got 2 by 3 pi, 4 by 3 pi, 8 by 3 pi, 10 pi by 3, and 14 pi by 3. So we got this part correct. And now these are essentially the same, so it doesn't matter. But in the exam, do not do this. If they ask in radians, do that. If they ask in degrees, do that. Please do not mix up the values. You're going to lose a lot of marks. Let's look at trigonometric relationships. We've already learned this in the previous chapter, but it will be a good revision. We have the first one, which is sine squared theta plus cos squared theta equals to 1. We proved this using a unit circle and using all the trigonometric ratios. If you want to check that out, go look at my previous playlist. And then we have tan theta, which is sine theta by cos theta. And the third one is tan squared theta plus 1 equals to secant squared theta. Finally, we have 1 plus cot squared theta equals to cosecant squared theta. Also, you should also remember the reciprocal ratios. So 1 by sine x is cosecant x, 1 by cot x is tan x, and 1 by secant x is tan x. Okay, so this might look like a lot right now, but you'll be really thankful that I've done so many questions, because this chapter is very crucial. It's even though you know the concepts, it's going to be hard for you to modify and try to solve them. So I will just solve a lot of questions right now, so it's much more clear. Let's start with this question. We have to simplify 2 minus 2 sine squared theta. So first we can factor out 2 from this. So this is what we get. And we know that sine squared theta plus cos squared theta equals to 1. Now let's write cos squared theta equals to 1 minus sine squared theta. Now we can substitute this into this. So we get 2 into, that is going to be cos squared theta. So this is our final answer. Now let's look at part B. We have cos squared theta into sine theta plus sine cube theta. Now let's take out sine theta. Let's factor this. It's going to be cos squared theta plus sine squared theta. This would be 1 because we've learned that. So it's going to be sine theta into 1, which is essentially sine theta. I hope this chapter is becoming much more easier and easier to understand. So now let's solve this one. Expand and simplify this. This essentially is this. Minus sine theta. Let's multiply this by this. It's going to be cos squared theta minus cos theta sine theta, again minus cos theta sine theta plus sine squared theta. Let's bring this together. Minus 2 cos theta sine theta. We know that sine squared theta plus cos squared theta is 1. So we get 1 minus 2 cos theta sine theta. This is in its most simplified form. Now let's look at this. In this we have to simplify this. This is very simple. We just have to factor out 3. And then this would equal 1. So that is 3 into 1, which is 3. Simple, right? Let's solve this. This is also very simple. We don't even have to solve this. This is minus 2. This is minus 1. This is that simple. Now let's look at this. We know that cos squared theta plus sine squared theta is 1. When we make cos squared theta the subject of the equation, we get the following. Now let's plug this back. We get cos squared theta divided by cos squared theta. Anything divided by itself is 1. Simple, right? Now let's do this. It's going to be the same thing. It's going to be sine squared theta by sine theta, which is sine theta. Let's solve this one. Okay, this is in the reverse order. This is basically going to be minus sine squared theta by minus sine theta. Minus sine theta and minus sine theta get cancelled, leaving us with sine theta. This is the answer. These questions in the book are much more simple than the questions that actually come. You'll have to use everything that you know in this chapter to solve them. Yeah. The book questions are very easy, so just look at past papers and try to solve them. Now that we've finished this, let's move on to this. In this question, we're supposed to simplify it. We have tan x cot x. We know that tan x is sin x by cos x into this would be cos x by sin x. This and this gets cancelled and this gets cancelled. We are left with 1. Or you can think of this as 1 by tan theta, and then tan theta by tan x by tan x would become 1. And hence that's the answer. This is also going to be 1 because they're reciprocal ratios. Now let's solve this. We know that cot x is cos x by sin x divided by cosecant x is 1 by sin x. This and this gets cancelled. We're left with cos x. And now let's solve I. We can write cot x as cos x by sin x. These two get cancelled. Now at the bottom we'll write cos x by sin x. And now we're left with 5 cos x. Now we divide this by cos x divided by sin x. Let's take this to the numerator. This will be sin x by cos x. These two get cancelled. We're left with 5 sin x. This is our answer. I hope it's clear. If you have any doubts, just let me know in the comments. And now these are the questions that will actually come in the exam. Whatever we've done till now is just practice. Okay, so we have this cos theta plus sine theta whole squared plus cos theta minus sine squared theta equals to 1. So the way you're supposed to approach this is write the following. On the left hand side, we have this. And now we expand this, we get cos squared theta plus 2 into cos theta sine theta plus sine squared theta. And then let's expand this. We get cos squared theta minus cos theta minus 2 cos theta sine theta plus sine squared theta. This and this gets cancelled, and we're left with 2 cos squared theta plus 2 sine squared theta. Let's factor out 2. This would be 2 into 1, which is essentially 2. And then you can write this is equal to the right hand side, RHS, and therefore prove. This is how you're supposed to write the steps. Let's solve this one. This is also very simple. 4 sine squared theta plus 12 sine theta cos theta. I'm not going to write the whole step, this step. I'm just going to directly get into this. Plus 9 cos squared theta. We have 9 sine squared theta minus 12 sine theta cos theta plus 4 sine squared theta. This gets cancelled. Sorry, this is cos, I'm so sorry. So this is gonna be 13 sine squared theta plus 13 cos squared theta. Now we can factorize it into 1, therefore proved. So yeah, and now let's solve this. We have 1 minus cos theta into 1 plus 1 by cos theta. We get 1 plus 1 by cos theta minus 1 by cos theta. These two get cancelled, and we have I'm so sorry, 1 second. Oh well. We have minus cos theta minus 1. This doesn't get cancelled, I'm so sorry. These two get cancelled. And we have this minus cos theta. We can write cos theta as this minus cos squared theta by cos theta. Since it's the same denominator, we can add the numerators. Divided by cos theta. We know that 1 minus cos squared theta is sine squared theta divided by cos theta. And now they want it in this form, right? So what we can do is write sine theta by cos theta into sine theta. We know that this is tan theta into sine theta. Therefore, proved. This is how you approach a question. And now let's solve this one. We have sine theta by 1 plus cos theta plus 1 plus cos theta by sine theta. This is the LHS. Now we'll multiply this by sine theta by sine theta. So we get sine squared theta plus 1 plus cos theta whole squared divided by sine theta to 1 plus cos theta. Let's simplify this. We get 1 plus 2 cos theta plus cos squared theta whole divided by sine theta into 1 plus cos theta. We know that sine theta plus cos theta is 1, so we can write this. We get 2 plus 2 cos theta divided by sine theta into 1 plus cos theta. Let's take 2 common, divided by sine theta to 1 plus cos theta. We can cancel these two and we're left with 2 by sine theta, which can also be written as 2 into cosecant theta. And therefore proof, because this is equal to the RHS. That's what they wanted us to prove, and that's what we did. And let's solve this final question from the textbook. We have 1 divided by 1 minus sine theta plus 1 plus 1 by sine theta plus 1 divided by 1 plus sine theta. Let's do this. Plus 1 minus sine theta whole divided by 1 minus sine squared theta. This is because a minus b into a plus b will be a squared minus b squared. We can write this as cos squared theta. We know that cos squared theta, 1 by cos theta is secant theta, so we can write secant squared theta, which is equal to the RHS. So therefore, proved. And now we're done with this chapter. Thank you for watching. Please do subscribe. And if you have any doubts, do let me know in the comments section below. Thank you.